Hello students, I am Dr. Nimi Singh. Today I bring you the next learning episode on an important unit of paper, Technological Methods in Forensic Science, that is Forensic Photography Part 2. Today in this lecture, we will be studying about the camera and its types. You will also be told about lenses and its types. In addition to it, you will also be studying about filters and their various types used in the field of photography. We will then end up this lecture with a brief conclusion. Dear students, let us have a look at the modules which we are going to learn today. The first thing that we will learn is going to be the camera and its types, then lenses, then types of photographic lenses, filters, types of filters for photography, and conclusion. Let us now come to the first part of our lecture series, that is camera and its various types. The word camera is derived from the Greek word kamara, which means room. At the beginning, it was a light-proof room or tent with a hole fitted with a lens and was used by the painters to trace image by pencil on a canvas or a paper. Later, this principle was utilized to attain the principle of recording image in a photographic camera. But to attain to its past form, some of the different discoveries were utilized. That is, in 1614, Angelo Sola's recording of the silver nitrate darkening property when exposed to the sunlight. Joseph Priestley's comprehensive description of chemical, of light and so on in 1772. The camera works in the same way as our eyes. The lens in the eye focuses the image on the nerve cell in the retina at the back of the eye, and this image is then sent to the brain by the optic nerves. After that, the ancestor of a camera came, and it is a light, tight box with the following parts: a lens to produce an image, a fitting to hold a light sensitive film or plate, a focusing mechanism for subjects of different distance, diaphragm, which is a sheet of metal with hole kept in between the lens, and photosensitive plate to control the intensity of light. Then shutter, a mechanical device by which the light entering through the lens is normally prevented from falling on the film, but it can still be displaced for a certain span of time by some button so as to pass the light for certain duration on the film for exposure. Then is the viewfinder. It is a device to see the area being photographed, that is, we can know the area being covered by the lens. Then the types of cameras. According to technology, there are film, that is analog cameras, and digital cameras. Both type of cameras function on same principles except the image capturing principles and a few minor differences. Presently, we will only be discussing about various types of film cameras. A film camera is made up of three basic elements: optical element, which is the lens, chemical, which is the film, mechanical, which is the camera body. Film cameras can be broadly classified into three types as per their size, mechanism, utility. The first is the view cameras. View cameras are built with a lens in the front, a viewing screen in the back, and flexible bellows in between. These cameras give sharp details, and what we see in the viewfinder is exactly what we get on the negative. In these cameras, we can change the position of the lens and the film relative to each other to correct distortion. Then is the point and shoot cameras. These cameras are easy to handle with simple features. P&S cameras can be further categorized into two types: compact and rangefinder cameras. Then we have is the twin lens reflex cameras, that is TLR. This type of camera comprises of two objective lenses having the same focal length. One lens is the lens which takes the photograph or the photographic objective, whereas the second lens is employed for the waist level viewfinder system. Both the objective lenses are connected such that the focus presented on the focusing screen will be exactly the same as on the film. Then you have is a single lens reflex cameras, that is SLRs. Single lens reflex cameras are more complex than any other type of cameras. Viewfinders of other cameras are quite simple and usually nothing to do with the main lens of the camera. Then you have is the specialty cameras. These cameras are manufactured for certain special purpose photography. Now let us shift to what do you mean by lenses. Camera lenses. Now first let us take this. Camera lens is a transparent medium, usually glass, which is bounded by one or more curved surfaces, that is spherical, cylindrical or parabolic, all of whose centers are on a common axis. For photographic lens, the sides should be of spherical type. A simple or thin lens is a single piece of glass whose axial thickness is less as compared to its diameter, whereas a compound lens consists of several components or a group of components, some of which may comprise of several elements cemented together. Lenses are mainly divided into two types, that is convex or positive or converging lens, concave or negative or diverging lens. Now convex lens is thicker at the central portion and thinner at the peripheral portion. It casts a real image and so can be used to take photographs. Convex lens can be further divided into four types: equiconvex, plano-convex, biconvex or double convex, concave convex or meniscus. Then you have is the concave lens. Concave lens is thicker at the peripheral portion and thinner at the center, exactly opposite to the convex lens. It cannot cast real image, so a single concave lens cannot serve the purpose of photography. Like convex lens, this type can further be subdivided into four types: equiconcave, plano-concave, biconcave or double concave, convexo-concave. In modern cameras, both negative and positive lenses are used, but the net effect of the combination should always be positive. Now let us come to the usual terms used for the lens. Optical center, it is a point within the lens through which the light passes undeviated or without changing the travelling path. Then we have is the principal axis. The axis passing through the optical center of the lens, which is horizontal when the lens is placed vertical to the horizon. Principal axis is actually the line connecting the center of curvature of its surfaces. Focus or the focal point. When a parallel beam of light passes through the positive lens, that is parallel to the principal axis, then it converges at a point and it seems to diverge from a point in case of a negative type lens. This point is known as the focus. Focal length. It is defined as the distance between the focus and the optical center. The photographic lens is basically depicted by focal length, generally denoted in millimeters. The determination of the focal length is made when the lens is focused at infinity. More the focal length, higher will be the magnification and narrower is going to be the view angle. Less the focal length, lower will be the magnification, but wider is going to be the view angle. Now focal plane, it is defined as the imaginary plane which passing perpendicular to the principal axis and through the focus. F number, it is the ratio between the focal length and the diameter of the diaphragm. Now F number is actually equal to F by D, where F is the focal length and D is the diameter of the slit or the diaphragm. The brightness of a lens is decided by a combination of focal length and the lens diameter. If the focal length of two lenses is the same, then the lens with the larger diameter will be brighter. For example, if the focal length is 50 mm and the lens diameter is 17.8 mm, the focal length divided by the lens diameter gives the lens a maximum f-stop of 2.8. F-stop has actually two meanings. One indicates the exposure settings aperture value, the other shows the overall brightness of the lens. The term f-stop indicates the brightness at maximum aperture and describes lens performance. Then is the resolving power. This expresses the capacity of a lens for rendering details, that is the sharpness and contrast of an image which can be casted by a lens. It is counted as the maximum number of lines per millimeter that can be sharply casted by the lens. The central portion of a lens can have a greater resolving power than the peripheral portion. Let us come to the next part of our module, that is the types of photographic lenses. Photographic lenses are divided into various categories according to their focal length, speciality and use. Although modern compact cameras come with integrated lens with variable focal length, however, only SLR cameras have the advantage where one can change and use almost any type of lens according to their requirement. There are three general classes of lenses which can be distinguished on the basis of their focal length. These are normal, wide angle, telephoto, normal lens. Now, the standard lens has a fixed focal length, that is 50 mm and 85 mm, and reproduces fairly accurately what the human eye sees in terms of perspective and angle of view. For a 35 mm film camera or a full frame DSLR, the 50 mm lens is considered standard. When the focal length is high, such as 85 mm or 100 mm, it is considered to be unique for photography, as when coupled with a wide aperture, they comprehensively soften the background detail, if any, thereby thus making it less likely to distract from the main subject. Then is a wide angle lenses. A wide angle has a shorter focal length, that is 10 to 42 millimeter, as compared to a standard lens. This results in capturing a relatively wide view angle. For capturing group photographs and outdoor landscapes, the wide angle lens is a natural choice. Indeed, wide angle can be the only way in capturing the whole setting without the omission of any important element in the image. Hence, the wide angle lens in this manner can be used to capture a deep depth of the field. Telephoto lenses. Telephoto lenses with 100 mm to 800 mm provide a narrow field of view. These types of lenses compress both the distance as well as the sense of depth and pick out particular objects from far off. These lenses have a characteristic shallow depth of field and a strong resolving power, wherein the slightest lateral moment can take a subject out of view. These types of lenses are mostly used in wildlife photography, sports and portrait, and in documentary. They enable you to capture subjects from hundreds of feet away. The normal and wide angle lenses are sufficient for most crime scene situations. Telephoto lenses, a telelens or long lens are less commonly used for taking photographs of subjects at moderate to far distances. True zoom lens is parafocal lens, is one that maintains focus when its focal length changes and is available for most 35 mm cameras. These are the complex lenses with provision for moving certain groups of internal elements so that the focal length can be varied continuously. The image quality produced with zoom lenses is generally not as good as it is with the high quality fixed focus lenses. This lens should have macro capabilities so that close-ups of evidence at crime scenes can also be taken. Apart from three general classes of lenses which can be distinguished on the basis of their focal length, that is normal, wide angle and telephoto, there are also other categories. That is the zoom lens. Zoom lenses are beneficial because they allow for a range of different focal lengths without the need to carry multiple prime, that is fixed focal length lenses. This lets the photographer quickly zoom in and capture the shot, then zoom back for another at a wider angle. Then you have is the close-up or macro lens. Close-up or macro lenses are used for close-up of macro photography. They range in focal length between 50 to 200 millimeter. These types of lenses require razor sharp focus for subjects within the distance of macro focus, however, losing their capability for sharp focus at other distances. Macro lenses allow the photographer to take life-size or larger images of subjects such as wasps, butterflies and flowers. On a strict note, the lens is said to be a macro lens only if it can have the magnification of 1:1. Nevertheless, the term macro is frequently used loosely to also refer to close-up photography, which is applicable for the magnifications of 1:10 or greater than that. Then you have is the fisheye lens. This type of lens is a specified type of wide angle lens which gives extremely wide images, changing straight lines into curves. By distorting the perspective, it can also produce convex, circular or oval images and thereby creating a 180-degree image. Tilt shift lens. Now, tilt shift lens enables us to manipulate the vanishing points. So, when you are shooting buildings, you can alter the perspective of an image so the parallel lines don't converge, thus eliminating the distorting quality of the lens. The tilt shift lens also enables us to selectively focus an image, where only specific portions of the image are in focus and out of focus within the same plane. Then you have is the teleconverters. It is mainly a magnification lens which is placed between the lens and the camera body. Wildlife and nature photographers use teleconverters as these lenses allow them to extend the photographic reach beyond a certain distance when they are in an unfamiliar location or on a safari. Usually saying the zoom lenses and wide angle lenses are not attuned with teleconverters, which makes sense. Let us now come to the filters. Filter is a device of glass or other material interposed between the scenes being photographed for the purpose of detecting or eliminating certain colors, generally to which the film is most sensitive, also called a color filter or an optical filter. Filters are camera accessories which modify the images recorded, maybe on any recording medium. Sometimes they are used to make only minor changes to images, other times they needed to create a major change in the images. Colored filter plays an important role to get the selected color and further enhancing the contrast of an image when placed over the light source or the camera lens. An object will appear darker in the photograph if the filter of complementary color is used. For example, if a filter of the same color is used, then the object appears comparatively lighter. If filters of black and white films are used, then they are called color contrast filters. The filter which is to be placed over the camera lens must be of higher quality, but there is no such requirement in case of white light source. Filters also change the color balance of images. So, photographs taken under incandescent light source show colors as they are perceived rather than a reddish tinge. But there are filters which distort the image as desired, diffusing an otherwise sharp image, adding a starry effect, etc. Supplementary close-up lenses can also be used as filters. Now, let us come to the different types of filters for photography. Generally, two types of filters are available: colored glass filter, gelatin dye sandwich filter. Another special type of filter often used in front of the lamp in color photography for special effect is called a lamp filter. A filter passes its own color while stopping its complementary colors to a varying degree. There are 5 main types of filter as per their usage. Correction filter. This is used to correct the imperfect color sensitivity of the film and make it to translate the subject into the tones of grey more or less, the same brightness as the colors appeared to the eye. It is used in color also to achieve desired color temperature. Filters never actually add color but only absorb certain wavelengths to increase the relative portion of others. So, the original light source must have the colors in it we want to start with. In the above example, when the subject is in shade on a sunny day and only lit by a clear blue sky using an 85A or 85B filter to correct for the excess blue will give the desired result. Any areas in the image that are in direct sunlight will take on a bright orange color as well. Then you have the contrast filters. Contrast filters are used to darken the reproduction of a certain color for special effects. In many situations, it is difficult to maintain a proper contrast, for instance, in bright sunlit exteriors. Exposing the film for either shadows or highlights will leave the other severely under or overexposed. A small amount of localized flare is created by the use of low contrast filters near the highlight areas within the image. This helps in reduction of contrast by lightening nearby shadow areas and leaving unchanged the highlights. Soft contrast filters comprises of a light absorbing element in the filter that, devoid of exposure compensation, will help in reduction of contrast by also darkening highlights. 5 types of color filters are used in black and white photography: red, orange, yellow, green and blue. Each of these filters now allow its own colors by blocking the other colors to varying degrees. For example, a red filter will let red light through but block most green and blue. The final image will have the colors brighter, for which there is a color matching filter, whereas other colors will appear darker. In black and white photography, this means that objects appear as lighter or darker shades of grey. Then you have is the color compensating filters. Color compensating filters are used to make adjustments to the red, blue or green characteristics of light. These types of filters are used in the correction of color balance, different reversal film batches, light source variations and other color effects. They are available in density variation of cyan, magenta, yellow as well as red, blue and green filters. These filters are different from conversion filters and color balance, wherein the color compensating filters control color by the attenuation of primarily the red, green and or blue regions of the visible light spectrum. Then you have is a special purpose filters. They are used to take picture by the light of a single color only. These are used mainly for scientific, aerial and other special photography as telephotography in infrared. Then you have infrared filters. In special circumstances, the use of color, infrared sensitive films of black and white films are required. For aerial haze penetration, recording heat effects and forensic photography, they are invaluable. In infrared filters, the tonal and color versions are very different, though from other types of films. Various filters are used to reduce unwanted visible light. Red, orange and yellow filters are used for panchromatic black and white film, can enhance contrast and alter color. Then you have is the neutral density filters. When it is desirable to maintain a particular lens opening for sharpness or depth of field purposes, or simply to obtain proper exposure when confronted with too much light intensity, neutral density filters are used. This will absorb light evenly throughout the visible spectrum, effectively altering exposure without requiring a change in lens opening and without introducing a color shift. Then you have is the polarizing filters. Polarizers allow color and contrast enhancement as well as reflection control using optical principles different from any other filter types. Most light that we record is reflected light that takes on its color and intensity from the objects we are looking at. White light, as from the sun, reflecting off a blue object appears blue because all other colors are absorbed by that object. A small portion of the reflected light bounces off the object without being absorbed and colored, retaining the origin and often white color of its source. With sufficient light intensity such as outdoor sunlight, this reflected glare has the effect of washing out the color saturation of the object. The waveform description of light defines non-polarized light as vibrating in a full 360 degrees range of directions around its travel path. Polarized light is defined as vibrating in only one such direction. A polarizing filter passes light through in only one vibratory direction. It is generally used in a rotating mount to allow for alignment as needed. Let us finally come to the conclusion of our lecture. A camera is a light, tight box comprising of lens, film, focusing mechanism, diaphragm, shutter and viewfinder. Various types of lenses and filters are used to capture specific scenes because photography is an important step in crime scene documentation. That's why the knowledge of lenses and filters are very necessary. With all these information, here we come to the end of today's lecture. Do keep in mind what we have discussed today. I will be back with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a great day.